We start with the generator, OSC module, writing to the red channel. In horizontal vertical frequency range, frequency equals 0.033 output 1 period. Let's start with the basic, non-symmetrical wave, so in horizontal frequency range. Second generator, another OSC but writing to the green channel. Signal routing is on, so red signal passes through. So wave shape, vertical frequency range, frequency equals 0.033. Time to do some blending. Tip: use non-red, green, blue colors for the modules that will output to all channels. 3 inputs with the scale and offset conditioning: A, B, and key. Mix selects how A and B blend. Each mode shapes the output differently. Blender out selects which channel the plugin writes to. Selecting red for a signal will use what's coming from above, on that channel. Selecting green for this signal will use what's coming from above, on that channel. Now, let's see the different blending results using one vertical and one horizontal saw. We'll see the keyer later. With non-symmetrical waves, offset shifts and scale resizes or skews shapes in X and Y. Animate these parameters with envelopes at different rates. Let's go back to defaults. Scale and offset equals 0.5. Change the blending modes and try different results. And back to defaults. Scale and offset equals 0.5. Now let's try different generators' wave shapes. More shapes. Input smooth. Slightly blurs input to reduce artifacts from limited resolution, limiting precision. Let's go back to saw wave shapes with the scale and offset on defaults. Time to add functions. One per OSC so we can process H, red, and B, green signals. Signal. Select the external channel to be processed by functions blocked from pass-through. Scale sets waveform height. Offset moves waves up and down. Math functions to process external signal. Invert. Functions output channel, routing and input smoothing. We're working on the red channel, so we select red for signal input and output. Log X. Compressor expand the signal range in a non-linear curved way. Algebra. Shape the signal using mathematical functions, x squared, x cubed, square root, and absolute value, creating curved or folded responses. As with Blender, changing scale and offset parameters resizes, skews, and shifts shapes. Depending on scale and offset, some functions will fold signal, mirroring it. Just testing different combinations with log X. Let's add the second functions for the green channel. Remember, you are seeing A signal red and B signal green combined in Blender. Lots of patterns, flexible control over the shape. Input smooth. Smoothing all modules to reduce artifacts at the cost of some precision. More and more patterns. Key. Blends A and B using key as a dynamic mask to reveal each. For this, we need to feed something to the key signal input. A third, blue OSC. Let's bypass everything but this last OSC. square wave shape to highlight A versus B. Fast forward, tweaking gets weird. There you clearly see the cut between A and B keyed by third, blue OSC. Let's do some conditioning. Sharp cut achieved. Just playing with some parameters. Let's add another oscillator to the blue channel as a modulator for the first. Fast forward some more tweaking. Going back to the other modes. Another OSC that will be modulated by this pattern we've just created. And test some combis. Since Blender out equals all, we have 3 channels with the same information. Selecting an individual channel, red, green, blue, will pass through the other 2. More and more tweaking. Oscillators. one is going first in the chain. Output equals all, so it casts to all channels downstream. We will modulate red and green first OSC, while those ones modulate their second. For red OSC, we do some frequency modulation. For green OSC, let's try some amplitude modulation.